You are on a 6-lane highway with nothing but open water surrounding you. No shoreline appears ahead, none trails behind. Left and right offer only endless gray sea meeting the horizon. A narrow strip of concrete carries you forward at highway speed through the middle of it all. You have been traveling this way for about 20 minutes. The feeling is extraordinary. Then the pavement begins a gentle downward slope. The way an approach road eases toward a river crossing. The horizon line climbs in your view. The water that has stayed level beside you starts rising relative to the car. You understand what is coming. The highway itself is about to disappear beneath the surface. Not by climbing onto a high bridge, not by boarding a ferry. The road descends into a dark rectangular opening cut into an artificial island and continues downward under the seabed for several kilometers. While you drive through that submerged section, enormous container ships the size of city blocks pass overhead, moving cargo from the Pearl River ports to destinations worldwide. They have no idea the road exists beneath them. This is the Hong Kong-Zhuhai-Macau Bridge. It stretches 55 kilometers across open water, making it the longest sea crossing structure ever completed. Within it lies the world's longest underwater road tunnel of its type. Engineers had to create 2 artificial islands from open sea, simply so the highway could dive and later re-emerge. All of this took place in a typhoon-prone region. When the project opened, engineers elsewhere examined the plans and asked the same question many still ask: why build it this way? They had no other workable option. The constraints formed one of the more unusual engineering puzzles of recent decades. Before we go further into the submerged section, tell me where you're watching from and what time it is there. Share your city and local time in the comments. Now let us examine why the road had to go underwater. To grasp the crossing, first understand the water it spans. The Pearl River Delta ranks among the most intense manufacturing zones on Earth. Cities such as Guangzhou, Shenzhen, Dongguan, Foshan, Zhuhai, Macau, and Hong Kong concentrate tens of millions of people in countless factories around a single estuary. Nearly everything produced there leaves by ship. The stretch of water known as the Lingdingyang Channel, therefore, carries some of the heaviest commercial traffic anywhere. More than 4,000 vessels move through it every day. Container ships, bulk carriers, tankers, ferries, and fishing boats in a continuous flow of steel that never fully stops. Hong Kong sits on the eastern side of that estuary. Zhuhai and Macau lie roughly 40 kilometers away on the western side. For decades, the practical options were a ferry or a long highway loop northward through Guangzhou. The land route often took 3 hours or more, especially with traffic. A direct bridge seemed the obvious solution. Designers explored that idea and quickly encountered hard limits. Any bridge over the main shipping channel would need extreme height, so that fully loaded large vessels could pass underneath without restriction. That requirement pointed toward very tall towers and a high deck in open water. Directly above the same stretch, however, lies the approach corridor for Hong Kong International Airport on Chek Lap Kok. Flight path rules impose a strict ceiling on structure height. The ships needed a tall bridge. The aircraft forbade one. No single height satisfied both demands at once. A further constraint, rarely highlighted in casual accounts, involved the local Chinese white dolphin population. Large-scale dredging and conventional reclamation would have disrupted their habitat with heavy silt plumes. The project, therefore, had to minimize disturbance to the seabed while still spanning 55 kilometers of open water in a typhoon zone. Height restrictions, intense shipping, environmental limits, and seasonal storms together created a problem that looked unsolvable on paper. Most teams might have stepped back. The Chinese design group instead chose an approach that initially sounds radical. In the middle of the crossing, the road would stop being a bridge, become a tunnel for several kilometers, and then return to bridge form again. Western engineers had already proven the basic bridge tunnel concept. In 1964, the Chesapeake Bay Bridge Tunnel in Virginia opened a roughly 28-kilometer crossing that dips into tunnels so ships can pass above. In 2000, the Øresund link between Denmark and Sweden combined bridge, artificial island, and tunnel over about 16 kilometers. Both projects remain impressive examples of their eras. The Hong Kong-Zhuhai-Macau Bridge applied the same principle at more than double the length of the longer precedent, in deeper water, under an active airport approach, through one of the world's busiest shipping lanes, over soft marine mud, in a seismic and typhoon region, and beside a protected marine area. Scale turned a known idea into a set of new technical problems that required fresh solutions. That brings us to the need for artificial land. A highway cannot simply plunge off the end of a bridge into open water. The descent into a tunnel needs solid ground to support the portal, ventilation, emergency systems, drainage, fire suppression, and monitoring equipment. On a conventional project, the shoreline supplies the ground. Here, there was none. Only open water and soft mud, roughly 40 meters deep in places. Before any tunnel section could be placed, 2 islands had to be created in the middle of the sea, one at each end of the submerged stretch. Each measured roughly 100,000 square meters of new land. Traditional island construction dumps rock and sand until a mound rises above the waterline. The method works, but is slow and requires extensive dredging that would have disturbed the dolphin habitat. Designers, therefore, used a different technique. They first formed the island perimeters with 120 large steel cylinders fabricated on shore. Each cylinder measured about 22 meters in diameter, wider than a multi-lane road, and the heaviest weighed more than 500 tons. The cylinders were floated to the site, held upright, and driven vertically into the seabed to depths of up to 33 meters by groups of vibratory hammers working in sequence. Picture steel tubes the width of a highway, taller than many mid-rise buildings, driven into the ocean floor like giant fence posts, then repeated until 2 complete rings formed watertight walls. Once the rings were complete, the interiors were filled and pumped dry. Open ocean became stable ground, protected by hard perimeters capable of withstanding typhoon waves. The islands took shape in months rather than years. The tunnel itself presented the next major challenge. One common method is boring with a large tunnel boring machine that grinds horizontally through rock. That approach built the Channel Tunnel between Britain and France through chalk. The Pearl River estuary, however, offers soft, saturated marine sediment near the surface rather than competent rock. Boring was not practical at the required scale and depth. Engineers therefore chose the immersed tube method. Tunnel sections are built on land in a dry dock, sealed, floated out, and sunk into a prepared trench on the seabed. The pieces are then joined underwater and covered. Instead of digging a continuous tunnel, crews assemble one on the ocean floor from large, prefabricated units. The immersed section measures about 5.7 kilometers within a total tunnel length of 6.7 kilometers. It comprises 33 main elements, plus a final closure joint. Each element was roughly 180 meters long, longer than a large airliner, and contained a dual 3-lane roadway plus emergency passages. Each weighed in the range of 76,000 to 80,000 tons, comparable to a major aircraft carrier. Every section was sealed, floated into position with tugs, and lowered in a carefully controlled flooding sequence onto a prepared trench about 40 meters below the surface. Alignment had to be accurate to centimeters. A misaligned joint at that depth would not seal properly and could lead to flooding in a structure carrying heavy daily traffic. Visibility in the silt-laden estuary water was extremely limited, so positioning relied on instrumentation rather than direct sight. The final closure joint, completed in 2017, represented one of the most critical single operations of the entire project. There is no second chance with that piece. The result is the longest immersed road tunnel of its kind, and a deeply buried structure unique at this scale. Stepping back to the full crossing, the system measures 55 kilometers. The main offshore portion is about 29.6 kilometers, of which roughly 22.9 kilometers consists of viaduct, and 6.7 kilometers is tunnel. 3 cable-stayed bridge sections carry the road over surface shipping channels. Steel quantities reached approximately 420,000 tons of plate, enough for dozens of Eiffel Towers, plus hundreds of thousands of tons of reinforcing bar and about 1 million tons of concrete. Construction began in late 2009, main works finished in 2017, and the link opened to traffic in October 2018 after nearly a decade. Design life was set at 120 years in saltwater, typhoon conditions, and a seismically active area, longer than many comparable structures elsewhere. One detail rarely discussed involves traffic rules. Hong Kong drives on the left, a legacy of earlier administration. Mainland China drives on the right. Somewhere along the 55 kilometers, every vehicle must change sides. At the boundary facilities, a purpose-built interchange lifts one direction of traffic over the other and places it on the opposite side of the road, a concrete solution to a political and legal difference. Hong Kong and Macau also maintain separate immigration, currencies, and vehicle rules. Private cars require specific permits. Most travelers use shuttle buses that run continuously between the 3 boundary points. The structure, therefore, encodes more than engineering. It physically accommodates 3 sets of traffic and administrative arrangements in the middle of the sea. After the islands, the tunnel sections, and the vast quantities of steel and concrete, what changed? The previous journey between Hong Kong and Zhuhai often took about 3 hours by the long land route or a ferry subject to weather. The new link reduces that to roughly 40 to 50 minutes and operates in most conditions. The western side of the delta had long been less connected to Hong Kong's port and airport. The crossing was intended to integrate that side more closely into the broader economic zone, now promoted as the Greater Bay Area. Traffic volumes in the early years after opening fell short of some original projections. Critics described the project as carrying political as well as economic aims, creating a physical link that ties Hong Kong and Macau more firmly to the mainland. Environmental questions about effects on the white dolphin population also remain part of the public record despite mitigation efforts. Those points deserve acknowledgement. Engineering achievement and political interpretation remain separate matters. Whatever views one holds about purpose, the physical facts stand. 2 islands, formed with steel cylinders driven deep into soft seabed, 33 massive tunnel elements positioned with high precision in limited visibility, and 55 kilometers of road, threading under an airport approach path and above one of the busiest shipping lanes on Earth. The structure exists and can be driven today. Return to the opening scene. You are again on the 6-lane highway with open ocean on every side and the road beginning its gentle descent. Now the reasons are clear. The highway dives because it could not rise high enough for the ships while staying low enough for the aircraft. The island ahead did not exist 2 decades earlier. It is held by a ring of steel cylinders driven tens of meters into the mud. The kilometers of tunnel ahead were cast on land, floated out, and sunk one section at a time in the dark with only one chance for each alignment. Overhead, container ships continue their routes, carrying goods from the world's densest manufacturing region, unaware of the roadway below. That is the Hong Kong-Zhuhai-Macau Bridge, the longest sea crossing yet built, and a highway that solves an otherwise impossible set of constraints by descending under the water rather than remaining above it. If you want to explore another Chinese structure that rises so high an entire skyscraper could fit beneath it with margin to spare, that account is ready next. In the comments, tell me, would you drive the full 55 kilometers, including the underwater stretch, or would you still prefer the ferry? See you in the next one.